Today we're going to talk about solving two-step inequalities. We've talked about solving one-step equalities with addition and subtraction and one-step inequalities with multiplication and division. And so far our goal has always been to get the variable isolated or by itself on one side. Just like when we were solving equations, just like when we were doing one-step inequalities, our goal is still to get the variable isolated or by itself. In order to get the variable by itself, we are still going to use inverse operations. The very first thing that we need to get rid of when we're solving two-step equations is the first thing we get rid of is addition or subtraction that is on the same side of the inequality as your variable. Then you're going to get rid of multiplication or division that is on the same side as your variable. So first look for addition or subtraction on the side with your variable, then look for multiplication or division on the side with your variable. You're going to use the inverse operations of each of those to get the variable isolated or by itself. The number one thing that you have to remember with inequalities is you flip the sign if you multiply or divide both sides by a negative number. So if we have to multiply or divide both sides by a negative number, we have to just flip the sign, which means if it was greater than, now it's going to be less than. If it was less than, now it's going to be greater than. Some examples of solving two-step inequalities. The first inequality we're given is negative 2x minus 3 is greater than 7. First, we need to get rid of addition or subtraction on the same side as the inequality. If you notice on the left side where x is, we are subtracting 3 from x. The inverse of subtracting 3 is adding 3, and we need to do that to both sides. When we add 3 to both sides, we're left with 2x is greater than 10. Negative 2x is greater than 10. Make sure you bring the negative down with it. Now we're multiplying negative 2 times x. The inverse or opposite of multiplying negative 2 times x is dividing by negative 2 on both sides. Now, when I am dividing by a negative on both sides of an inequality, my sign flips. So instead of greater than, now I'm going to flip the sign and it's going to be less than. So x is less than a positive 10 divided by a negative 2 is a negative 5. The next example is c divided by 7 minus 4 is less than 0. First, I need to get rid of addition or subtraction. On the same side as my variable c, I am subtracting 4. The inverse of subtracting 4 is adding 4. Whatever I do to one side, I do to the other. So I have c divided by 7. My 4's are going to cancel out. So I have c divided by 7 is less than 0 plus 4 is 4. Now I need to get c by itself. My next step would be to get rid of dividing by 4. Dividing by 7. The inverse of dividing by 7 is to multiply by 7, and you need to do that to both sides. I'm multiplying by a positive on both sides of my inequality, so nothing happens to my inequality sign. I am left with c is less than 28. The next example is negative 9 is less than or equal to negative d divided by 5 minus 1. Get rid of addition or subtraction first. If you look at your variable d, I am subtracting 1 on that side. The opposite of subtracting 1 is adding 1, so I need to add 1 to both sides. My 1's are going to cancel out on the right side, and negative 9 plus a positive 1 is a negative 8, is less than or equal to negative d divided by 5. Now, when you have the negative d divided by 5, we need our variable to be positive. I know I need to multiply by 5, but I'm going to go ahead and multiply by a negative 5 because remember, a negative times a negative is a positive. So when I multiply by negative 5, the negative and the 5's are going to cancel out, so you'll just be left with d. If you're multiplying by negative 5 on one side, you have to multiply by negative 5 on the other. When I am multiplying by a negative on both sides of an inequality, I have to flip the sign. So instead of less than, I'm going to flip the sign to be greater than. A negative 5 times a negative 8 is a positive 40, is greater than or equal to, because I had to flip the sign, D. The next example, we have 20 is greater than 2 minus 3x. We need to get rid of the whole number 2. In order to get rid of a positive 2 from one side of the inequality, I have to subtract 2 from both sides. When I subtract 2 from both sides, my 2's are going to cancel out. 20 minus 2 is 18, so I'm left with 18 is greater than a negative 3x. Remember, your subtraction sign becomes a negative sign. Subtraction and negative signs are the same thing. So when you have a negative 3x, we need to get rid of the 3, the negative 3. When you're multiplying negative 3 times x, the inverse of multiplying would be to divide by negative 3 on both sides. Because I am dividing by a negative on both sides of the inequality, I have to flip the sign. When I flip the sign, a positive 18 divided by a negative 3 is a negative 6 is less than x. Notice my sign has gone from greater than to less than because I had to flip it. If you remember talking about the scales when we were talking about addition and subtraction inequalities, notice in this scale, on the left side, I have 2 orange circles which each count for 1 because they're each labeled 1. And then I have 4 purple squares that are each labeled X. Notice on the right side, I have 10 ones or just 10. Remember, on a scale, whichever side is down further is greater than the side that is up. So in this case, my inequality needs to be open towards the 10 circles or the right side of this scale. So I know that my inequality sign needs to be less than because it needs to be open towards the side that measures 10 because in the scale it is pushed down, and whatever side is down has more on it. Now, when you look at the left side, you have 2 orange circles and 4 purple squares. The 2 orange circles are each representing 1. So if you just count them, you have 2. And those are just a whole number 2. Plus, you have 4 squares that are representing an x. So altogether, you have 4x plus 2 on the left side. And on the right side, you just have the whole number 10. Now I've set up an inequality, and now I'm going to need to solve for x. So I'm going to start with 4x plus 2 is less than 10. I need to subtract 2 from both sides. When I subtract 2 from both sides, I'm left with 4x is less than 8. To get rid of the 4 that I'm multiplying by your variable x, you need to divide by 4 on both sides. When you divide by 4 on both sides, you get x is less than 2. So the solution to this inequality would be any number that is less than 2. The next example, we're given another scale. Notice in this case, my left side is down, is pushed down on the scale. My right side is up. This means that on the left side in this case, that side would be greater than the side that is on the right, or the side with all just the orange circles. So in this case, my inequality needs to be open towards the left, which would be the greater than symbol. When you look at the left side, you have 2 1s again, and in this case, you have 3 x's. I can write the 2 1s plus the 3 x's as 3x plus 2. And if you look on the right side, you have 11 ones, which would just be 11. Now I've set up an inequality. I need to solve the inequality for x. To do so, I need to subtract 2 from both sides first. When I subtract 2 from both sides, I'm left with 3x is greater than 9. Now your goal is to get x by itself. I need to use inverse operations. The opposite of multiplying by 3 is to divide by 3. When you divide by 3 on both sides, your 3's cancel out. 3 divided by 3 leaves you with just 1x. And your x is going to be greater than 3 because 9 divided by 3 is 3. So you've solved for your inequality for the scale. You know that x can be any number that is larger than 3 or greater than 3. Today's assignment is on page 200. It's numbers 8 through 34 even, and then numbers 39 through 41.